Hello, everybody. Welcome back to another forecast. Today we're looking at our moderate risk for tomorrow, which seeing this video tomorrow, talking about the 25th. So if 25th, this risk might look different, but I'm making this the night before this event. Now this is for our moderate risk for May 25th here. This is today, and this is the day 2 outlook. So already a moderate risk on the day 2 outlook. 15% hash tornado risk. Really, all hazards are at play here. Large hail for anywhere. Like they said, SBC said giant hail of up to 4 or more inches. Extreme hail over 4 inches is expected. Wind damage corridor here in Kansas, and of course, this huge old tornado risk over much of Oklahoma and southern Kansas. So, a lot of cities in this. I can even zoom in to see this. We have Oklahoma City, Wichita, all sorts of cities in here are within this tornado risk area. Population of 3.5 million in this 15%, and the area as a whole have or significant severe, excuse me, that'll be your patch region. That's already almost 5 million people there, all in this risk area. So big old risk here for this day. I'm going to be looking at what our parameter space looks like for it. Here's our 500 millibar level here. This is basically tonight. This is our 21Z HER from today. So this is a few hours ago. This is about 5 hours ago. Again, when you're watching this video, stuff might be a little bit different here. But I think they upgraded to a moderate risk because of one of our most recent H2R runs, which showed lots of discrete cells all along this Oklahoma frontier. Get my pen out real quick too. Here's our 500 millibar level here. Skip through all my ads real quick. All right, so there we go. Okay, we're good. Here's our surface low first, but I want to look at 500 millibars. We have that big old trough that I was talking about, right? We have that polar jet stream, which is kind of they're moving together with the subtropical jet stream. And what's happening is we have a very large amplitude trough in the west here. It's going to eject tomorrow, right? Here's a very large amplitude here, and not really, not very meridional, very zonal. So our flow is very much west to east, not so much not like one of those surface flows that looks, or sorry, not one of those troughs that looks more like this. We end up with a lot more flow like to the north, and that can lead to more linear modes. This is much more discrete for our cells. Again, very meridional here, and you can even see a little bit of a 500 millibar jet streak right here of Oklahoma, right around storm hour. We also have a bit of a shortwave at the same time. You can see it pretty well defined here. Kinks in the flow right along here. There's a shortwave somewhere in this vicinity. That's also going to help our forcing. You can also see this because of the fact that we have a little bit stronger flow around here, right in this vicinity. So you got to do a few short waves. You can also see it pretty well right down here, I believe. There's your there's little kinks in the flow. Then I'll move its way right up into Oklahoma as the day goes on. That especially developing right here. So that really helped force some of the storms up as well, and it's also more subtle forcing. Speaking of dew points, today's setup we had a lot of wind damage here, or more of a wind line here over Illinois vicinity and kind of this Arkansas area. However, this cold front that swept through there didn't go too super strong. You can see here's the wrap model here, but it doesn't really push out the moisture as you'd expect, especially considering this very strong trough that's now moving over the United States, so associated with a very strengthening surface low here. Our dew points are zooming way back north again. Very quickly, this moisture returns right into Oklahoma, with 60s dew points reaching all the way to Nebraska within a few hours, like within one day of that storm system going through, as well as the overnight hours here. I mean, the surface level really brings these 70s all the way up here, very high up into the north. We'll look at this tomorrow setup now at this point, but yeah. So here's our storm hour on Saturday. Again, our storms aren't going to fire until more of the evening hours, right? You can see here because this moisture still has to return the area, right? These storms won't really be able to go very far without the moisture. You can see at 15Z on Saturday, that's about 10 p.m. or sorry, 10 a.m. Central Time. Not really much going on for the storms as a whole, right? Or any storms that want to form. Like 50 dew points here with a 70 temperature. That's a 20 dew point spread. But as the day goes on, the moisture will turn. You get a very well defined dry line here, as well as the cooling air. You get 80s dew or 80s temperatures here at this station, 71 dew points. It's a much better return. And that's when our storms really start to form. Is right when this dry line starts to tighten up right here. That's when our storms will start to fire right around 22, 23, 24, or sorry, and 0Z for Sunday. Now the HRRR, let's look at that. This will help us see reflectivity. Basically shows the exact same thing considering it is with a rapid refresh model. You can see here 22Z, 23, and 0Z for the next time. All those storms forming right in, as I was saying, right when that dry line will kind of converge and tighten up, right? A little bit looser right before it, but at 22Z you have a 60s and a very stark dry line right here. And that's when our storms start to fire again. It's a little bit messy because of all the lifted index stuff going on here. You can see our better colors here. More simple that way. 70s and very high 60s dew points across this whole region. Now, one thing to note though is the NAM actually is a very different outlook on this. So if we look at the 0Z NAM, there is still that somewhat, supercellular look. But it's not nearly as intense as the HRRR model. Here's the HRRR model. Here's the NAM. The NAM regarding dew points actually has kind of this missing area right here and a much less defined dry line. Something to take into account. You look at the RAP model, much better, well defined right near Oklahoma, but the NAM model kind of has these little gaps in between, right? That's something to keep in mind. Maybe that could be an inhibitor for this setup. Oh, I did forget to look at Cape. Cape is definitely in this system though. Here's the RAP. Let's go to where we need to be. Oops. Wrong model here. Alright, here's right at 23Z. I already have very high Cape here. About 5,000 across the whole region here is above 3,000 Cape. It's a very good Cape. That definitely will help for our hail. What I'm going to do is actually look at the HRRR, take a few soundings from the RAP, right? First, I'm going to take RAP soundings from these very few first storms that might be forming here. So right along this dry line, I think I one right here. Here's our first sounding I'll take. I'll take one from a little bit after into the environment these storms will be moving into. You can kind of imagine, if we look at HRRR, look at our reflectivity, these storms will move on this way over a few hours. I'll take a sounding from right here to kind of see what that environment looks like. And here's our first sounding. Curious why I don't believe it was supposed to get that hot according to the RAP model. I'm a little surprised by that. Definitely is a region of warmer air that could help to stop some of this convection early on, which is something to take into account. And kind of unique why this one storm according to the HRRR forms right there. Because they could start out being hail based, so that is something to take into account. As well as the fact that this is a little bit removed from our area. This is more of a Texas sounding, so I might want to take one from more north. More north for, yeah, better sounding will come from. Our main tornado risk is going to be more this Oklahoma region. So this is our first look, though, in that Texas region. That could be more of a hail risk, right? See, the hail very much extends down to Texas. These first storms are going to be very hail-based. You can see here, there's a very much inverted V, 97 over 67. That's a 30-degree dew point spread, and also maybe more of a wind damage. But you can definitely see very supercellular. You have that little bit of shear, not really much in there at this point. You have that jutting off of winds as you go up with height. Very good for supercells right here. Possible wind damage here as well, though. Our next sounding for the Oklahoma sounding is much different. A very slight cap here in place, which could help inhibit the storms, but there's also a lot of forcing in the system, so these storms might be able to break through that cap. A7 SIN is, that's a decent convective inhibition, but again, with how much forcing there is, it might be enough to break through this cap. Also, very good shear in the lower levels. You can see it right here. There's your turning. You also see in the photograph again, plenty of rotation, lower levels, shutting off of winds, maybe a little bit of decrease in that 1 to 3 kilometer range. You definitely have what you want to see in there. I also want to take a sounding from the Nebraska area. So we can see here, have that huge destabilization. And by the way, very long track supercells here. These are very likely to persist throughout the entire evening. But the other damage that we have for this moderate risk is our wind damage in the Kansas, not Nebraska, in this Kansas vicinity. 45% hatched wind area here. So 30% and 45% right in this little region here in Kansas, parts of Missouri. I'm going to take a sounding ahead of that as well. You can see if our Kansas thing, very similar to Oklahoma, less destabilized across the whole vicinity. The guess is that some of these storms from the outflows of these storms down here be more forcing for all this Kansas convection. So I'll take a sounding ahead of this as well. See the environment that could be looking into. And the tornado risk, let me find the SPC over here. Tornado risk does stretch up there into Kansas, but it's not as strong as it is in that lower Oklahoma region. Here is our Kansas, Oklahoma sounding. Yes, tornado according to this hazard type. I don't know how much I trust that just because the cap in place, but you still have that supercellular look backing in those 1 to 3, 1 to 4 area, setting off of the winds, and definitely good shear there, curvature in the lower levels. Especially here, you can see that southerly flow moves to easterly flow or westerly flow very quickly. Recape at 57 joules per kilogram, not as high as you'd want to see, but with supercells, recape is not as important. Yeah, hail again. Hail early on. Hail and tornadoes kind of combined actually. So I'm curious how that'll turn out. Also, one thing to mention is the fact that the SPC does say only reduced confidence in total storm coverage is precluding a high risk at this time. The SPC almost wants to issue a high risk, but the only thing they're wondering is why does the storms not look like they're going to all really cover enough area, right? So look at Oklahoma here, our HRRR run. See definitely a line of supercells here, but all these other models don't really show it as well, especially the NAM is a very critical outlier. I would trust the HRRR a little more for short range stuff, but I mean, the NAM not showing this at all is very interesting to take into mind. I'll try to look at the HREF. I like the ensembles here. I've been trying to use this a little more as well, just because ensembles are important. Fortunately, these don't really seem to go far enough. I did look at these other models by hand. Here's our HRW. This is showing something very similar. More of a southern look, so more of Texas in this case. But basically the same thing. Very widespread coverage in this case. Look at this one. I don't think this has enough range. But yeah, you can see, no, this one does have enough range. You do get some of that destabilization around about 23Z. Now let's check these other models. Here's the WRF RW. A little much earlier in this case, 21Z. Already, or actually more like 19Z in this case. Less nocturnal storms in the Oklahoma area, but generally the same thing with very widespread storm coverage. So I'm curious, we might see a high risk tomorrow. It'd be interesting. Very discrete modes here. You can see here even very supercellular. You can kind of see those the flying eagles in this case. Again, here's another example of less storm coverage. Oklahoma, you have a few discrete options, but a high risk wouldn't be warranted for a few discrete cells that could go and be very powerful, but not widespread coverage. So that's the main reason they have that high risk at the current moment. Otherwise, that's about it for this video. I might be able to get an update post out tomorrow, but this is the main time I had for this video, so I apologize for it to be later in the day. I did hope to have more data from the morning HRRRs, maybe the 12Z run, so hopefully if the 12Z run comes out in time for me, I can make a post on it and check it out. We'll see if we see any high risks tomorrow. Again, tomorrow's a very potent day, don't forget that. Very potent. This is nothing to scoff at because it's not a high risk, but it's a very impressive setup here. Definitely possibly just a huge line of discrete supercells as well. So it's a very potent day, something to look out for. But for this video, that is about it. So thank you for watching. I will see you next time.